thanks everyone for coming to Bangkok. This is the Works on ARM Birds of a Feather session. I should give a brief introduction to the Works on ARM project, and then I'll ask people who know something about it to share any experiences they currently have or any questions they have about how it works, and hopefully try to both convey the progress to date and direction for the effort. So I'm Ed Vielmetti. I work at Packet. Packet is a bare metal cloud provider based in New York City. I'm in Michigan. The Works on ARM project started about 2 years ago with some funding from ARM to provide infrastructure for open source projects that were looking to either port their software to ARM, or as we got further along, to make it possible for people to do continuous integration and continuous development. So get beyond just the proof of concept stage where software works once and then it stops working when the next release comes out, all the way to nightly builds or continuous builds for complex software systems that work over a long period of time. So as we started, it was like we're not really sure who's going to be interested in this. As it came along, it became fairly clear fairly quickly that there were a couple of groups of organizations that for which this was really key. Operating systems development is an easy sell because these organizations are doing lots of builds across a big package base, or kernel development, or other sorts of things where having bare metal hardware really makes a difference. We also picked up a bunch of language families, so GCC, LLVM, Go, Adopt OpenJDK, the Julia language, which is a scientific computing language. Basically, anyone with any kind of plausible CI system that wanted to do a port to ARM and keep it working as the language evolved, we've been able to provide resources to that. Unfortunately, we didn't catch every language, so the Python people never showed up to knock on the door, and as a result, so there's some gaps right now that I wish I had a proposal from someone to say, hey, we're going to do Python on your platform, how can I do it? And I would say yes. So, or knock on their door. Or knock on their door.
Yeah, I think the answer there is just open a PEP and see what happens.
Open a PEP and see what happens. Yeah, it's so one of the challenges of broad level support, right? It's not a narrow, we want this stack to work. It's more a very broad, we want everyone's stack to work, is an appreciation for the diversity in this environment. There are a lot of different build systems out there. There are a lot of different languages. There are a lot of different operating systems. People have very diverse build systems that in turn require diversity of software to work for that to work. So there's just, because of that, it's been an education over a couple of years of like, how many different ways can you build a piece of software? And how many different ways can that go wrong on a new architecture? There have been some really good successes. Hi, Rico. When I got started, the first thing I wanted to do was to get Docker to work so that I could run containers. And the first thing I discovered after some amount of bouncing around between projects and whatnot was discovered a bug in the Go programming language where it didn't behave correctly if you ran it on a machine that didn't have a 64K page size. And this mysteriously turned into a file system bug in Docker, and I can't tell you how many different, like, people would just give up, right? They would say, oh, it doesn't work, it's flaky. It's just flaky, it just doesn't work. So, you know, going up and down the rabbit hole of, is it a language problem, is it a code problem, is it a environment problem, what have you, and eventually getting to the point where I could replicate the bug and prove to distro people that yes, they needed to upgrade their version of Go because that would fix their Docker problem. So that's some of the work that I do. Much more of it is enabling other projects to solve these problems on their own, to have enough resources so they can do builds, have enough compute time so that they're not taking 2 hours or 4 hours or 24 hours to get something going. And also to provide a community spot. We run a Works on ARM Slack channel inside the Packet community Slack. We do a weekly phone call over Zoom. I put together a weekly newsletter when I'm not traveling, and just keep people up to speed of what the ecosystem looks like and how they can get involved.
And Ed's also being a little bit modest. The other thing that he does that is absolutely incredible is knowing everyone and being able to connect people back together. So when somebody comes with a problem for a particular thing and it turns out that the bug is in that build system, he can be like, go talk to them to try and get that build system fixed, and we'll provide you the hardware to help.
Yeah, it's been interesting. Like it's a couple years worth of like collecting projects, collecting people, collecting common issues, whatnot. So I'd like to stop talking at this point and ask questions of folks. Carl, if you want to run the microphone. Sort of first question is, if there's anyone in here who's actually actively using the system right now. Riku, you want to give a brief intro and explain how you're using it and how it could be better?
So we are using it in Debian for one of the build machines, and we're really thankful for it. We're also thankful for the PacketNet support for Linaro in general.
Good. And it's what particular build system is it running? It's Debian's own builder, or is it something I've heard of outside of that?
Both the Debian's own builder, and then we use it as part of our Jenkins infrastructure.
Okay.
And is that just doing, yeah. So is that just doing ARM64 builds, or are you also doing 32-bit stuff at the same time?
Just ARM64.
Okay.
It's, I think, the 32-bit only, 64-bit only machine.
Right. So the inventory that we have to apply to this problem, opportunity, is a bunch of our C1.large.ARM machines, which are KVM Thunder Axe, which are 64-bit only. We have a handful of Thunder X2 systems, which are interesting because they actually have a different, they're ARM v8.2 instead of ARM v8.0.
Yes, and also requires having a 4K monitor to run HTOP.
Right, it has 224 cores or
Yeah,
threads.
it's massive.
It's massive. We have some Huawei gear based on the high silicon high 1616 chip, the Taishan, I want to say 2280. Again, a handful of those. We're getting online a bunch of Qualcomm Centriq stuff that was decommissioned from a cloud vendor that didn't want to have out of production equipment, but still wanted to have it online. So some of those are going to go to Windows 10 on ARM builds. Others are going to go, I think, to an OpenStack cluster, and then whatever's left over will be part of a pool of things. And then our latest gear is Ampere eMag. So that's going to be primarily for commercial use at the start, but if people have outgrown the systems that they're currently using, that's a possibility.
Yeah, and as a bonus, the Amperes and the high silicons are 32 and 64.
Both Thunder X2 and Ampere.
No, the Ampere and the high silicons are 32-bit and
32,
64-bit.
64, yeah. And I'm sort of working through, we've had, because the Amperes do 32-bit, there's a certain dance that you can do to create a 32-bit only build environment, which involves nothing that anyone has ever really packaged up yet, but either libvirt-based stuff or replacing binaries with the certain binaries that do the right thing. So there's some.
I found that just using Linux containers works pretty well for that. Like, doesn't even have to be anything fancy Linux containers, like not Docker or anything, just LXC.
Just LXC.
Yeah.
So good. Can I call on you to describe the project that you talked to me about in the back and introduce
Sure.
yourself?
So my day job is working for ARM on Yocto Open Embedded. And so that's a lot. Now it's mostly cross-compiling from x86 and using Packet to do native builds is extremely interesting. And then the use case that was brought up to me actually yesterday, so funny how things happen quite quickly here, was doing nightly GCC snapshots, because all the GCC stuff ARM is upstream 100% all the time. So if we could do nightly GCC snapshots and compile an entire Pocky and then run it every single night, we could very quickly catch GCC bugs, OS bugs, yada, yada, yada.
Yeah.
So that's the use case that was brought to me and I think is extremely interesting and compelling.
Yeah, that's a pretty typical need, right? Where the requests that I get run the gamut from, hey, I'm doing one program, I want to make sure that it ports and works, all the way up to, I have this extraordinarily complex system and I want to test it continuously. For the get one program to work over and over again, we've also partnered with a couple of different cloud CI providers, Drone and Shippable and CodeFresh, so that you can essentially stick a config file in your GitHub repository and have it schedule builds, as that's triggered, both on ARM32 and ARM64 and x86.
Very similar to Travis CI.
Very similar to Travis CIs. Yeah, we definitely saw the need for, like, the unit of compute that I can easily hand out is the machine, right? For some projects, the machine is about the right amount of stuff that they need. For others, they need a fraction of a machine for a fraction of time. And assembling the resources necessary to do that has been, like getting CI systems so that you can just schedule it on their farm and have that go, rather than build your own Jenkins or build your own build bot or what have you.
Out of curiosity, how long do these nightly builds wind up taking? Most of the day?
It depends on the hand waving, depends on
Of course,
number
yeah,
of
of course.
cores, how much you're building, because with
Right.
Yocto you can do a very minimal install, you can do everything that's GUI, you can do every package in the universe. Sorry, I'm Christina Aguileraing here.
It's fine.
So yeah, on x86 on, let's say, an 8-core, it takes for about 2 hours to do a average size build, let's call it.
Sure, okay.
A minimal build can be a little bit less than an hour.
So I was thinking, like, in the terms of wanting to do a nightly GCC thing, like, do you know approximately how long that takes? Or is it all so brand new that no one's even tried running it yet?
Well, so because Yocto built everything from scratch, it would be
okay.
roughly the same amount of time, because you'd be fetching it from this specific
Got it. Okay, makes
Git
sense.
tree. Yeah.
Sorry, I'm not super familiar with Yocto yet.
Cool. I'm happy to educate as much as I can.
It's on my list.
Good. Yeah. So as I said, like, getting languages to work is high priority, just because if you can't trust your compiler, like, nothing else works. Getting operating systems to work, operating systems almost always have such a breadth of things that they're trying to do that surfaces a lot of issues really quickly. We've tried to provide resources for people doing orchestration. So if you've got, if you're doing a Kubernetes installer or whatnot, there's other support at Packet for doing, like MetalLB, for doing load balancing, whatnot. So we've started to be able to provide some resources to that sort of cloud native world. That's proving to be especially tricky, in part because often people need a bunch of resources to just try it, and also because the cloud native world has a lot of x86 first code, so you have to port before you can test. Yeah. Which is fine, but it adds to the
Heavy lift operation.
it adds to the complexity of things. Yeah. So as part of Works on ARM, we have enough resources that we can contribute to these projects as well as just contribute labor to the projects as well as just providing hardware. So my colleague Avi did a port of Project Calico, which is a networking for network overlay for Kubernetes, and that I think he didn't think it was going to be a 6-month project, but it turned into a 6-month project because in order to get a completely clean build on ARM, you had to port the build system for 6 or 7 different components in 3 or 4 languages.
And you had to make all of the container repositories multi-arch aware.
Yeah. And you had to do this all with knowledge of the politics of the projects and to have it be a friendly operation the whole time.
Yep.
And in a lot of cases, the human relations aspect of things are more important than the technical aspects. Right? If a project sees that you can bring to it a community and that you can add some things to it, and if you're providing support for their whole project and not just for this new thing you've asked them to do, Packet is a good spot for that because we've got resources to do things like mirrors. So often the first engagement with the project is not on the ARM front. It's like, hey, Alpine Linux, do you need some mirrors so that we can download your stuff? And then, oh, by the way, we've got this ARM hardware. You've got a port started. Do you need help? You know, like multiple levels of engagement from a technology side. And then, as you pointed out, also multiple levels of engagement from a community side, bringing resources that we've identified from one project and teaching people about something else.
Yeah. To tune our own horn a little bit, like one of the things that I really love about our company is that we give back a lot. We host kernel.org, which is just awesome. And also hysterical because I was doing a git pull from kernel.org one day and I was like, why is this so slow? I'm literally like 3 racks over from them. But yeah, it's entertaining. You know, there's of course layers upon layers upon layers upon layers of infrastructure for stuff like, you know, the main Git repository that everyone clones out of, which actually isn't hosted with us. It's on a massive CDN network that's provided by Fastly. Just because, holy cow, the amount of bandwidth that generates. But even then, like the amount of bandwidth that gets pushed through those boxes for hosting kernel.org is really impressive.
Yeah. Yeah. So we're always on the lookout. You know, again, resources willing. The project has been funded by ARM for the past couple of years with a very, I don't know if we had a broad mandate, but I took it as a broad mandate. So like, if someone is reasonable, we should say yes to them. Trying to make sure that as the project goes forward, I keep enough of that broad mandate because every once in a while you discover that something that you're working on is actually a dependency for the thing that you care about. Like, yes, you really have to care about Java, even if you don't think that that's a primary language for your next $1 million deal, because
it's amazing how much Go is generated by Java.
Yeah, just dependencies up and down the chain of like your build system is built in this, so you have to just.
Yeah, well, so Go being a orbital escapee of Google, lots of things that are made in Go also use build systems that are also open source orbital escapees of Google, meaning like they're open source, but they still very much sit in Google's orbit. And so all of their build stuff is primarily written in Java derivatives, so it all runs on the JDK. So those have to get ported in order to get things like Kubernetes to build.
So it's been entertaining. It's been a good learning exercise for me because I thought I knew how software worked, and then you discover after a couple years of working on it that you have no idea how all this menagerie of things stays afloat. And
baling wire and duct tape.
and thrust.
Yeah, and thrust, yes.
Probably so thinking of futures, right? Thinking of bigger opportunities. As the project evolves from its original spot, which was primarily a single vendor KVM Thunder Axe hardware platform, we now have a diversity of hardware. Some of those have instruction sets in them that are, not completely different, but different enough that people doing compiler development care, right? They understand things. I would love it if the ecosystem was in a place so that when ARM announced, v8.2, ARM v8.3 or ARM v8.4, even if we didn't have a big sample of actual chips, that we had enough actual chips to host the key compiler folks there.
Yeah.
Similarly, there's scalable vector extensions that are coming, right? I would love to, even if I don't have 1,000 SVE machines, I would love to have one, because I'll happily timeshare it amongst everyone who needs it.
Yep.
To get that support going, and having that sort of neutral interface to the whole community to try to reach out to those folks.
So on that point, like one of the things that I wanted to try and bring up a little bit is we value communication and feedback with the community. Like if you guys have ideas, guys and gals, excuse me, if you have ideas of what you would like to have, things that you'd like to see Works on ARM do, technologies that you think are interesting that you'd like to bring to our attention, like, yes. Come shoot us an email.
Yeah.
Come by the.
We have a booth upstairs.
We have a booth upstairs. And we didn't have it this week because we're all here and it would have been in the middle of the night. But we have a Works on ARM session, like I said, on Zoom every week. You can go to worksonarm.com. We'll have the links on there. Come hang out with us. Like you don't have to sit there and be like, oh man, are they just going to talk about continuous delivery engines the entire time? I mean, honestly, we typically just go through CNX software and talk about all the cool things that we found on there that's ARM related. So come in, bring conversation. We love to know what's going on because that helps us figure out how to continue to best serve the ecosystem.
Right.
And didn't I see that you also have an IRC channel that you're on?
There's an IRC channel, Works on ARM.
Works on ARM on Freenode.
That's on Freenode. That's gatewayed to a Slack instance on inside Packet, and that's I think. So just to get a sense for community size, the newsletter goes out to about 250 people. The Works on ARM Twitter feed has like 800, 900 subscribers. The Slack channel and IRC, it's hard to count IRC people, but the Slack channel has on the order of about 800 or 900 subscribers. So, that's not 1 million developers.
No.
But it's also not 10. and people find us, I mean, frankly, people find us who have no connection to ARM corporate and who don't know anyone at any vendor. They just know that they bought something and they tried to get it to work and they want to share their experience.
Yeah, and like as an example, like the conversation in the Works on ARM Slack and IRC channels the past couple of days has been folks doing ZFS on Linux on little ARM boards and figuring out how to make all that go and everybody helping each other trying to make it work. And
With the intention of building a NAS?
yeah.
Yeah.
Yeah, so using the Orange Pies?
The fellow who's doing it is the Lollipop Cloud
Yeah,
guy.
he's from Lollipop Cloud, and it's the NeoPi or the NanoPi. There's a expansion board that you can drop on top of one of these little Raspberry Pi derivative things that gives you 4 SATA ports. And so he's running that, and then he's been working on getting ZFS on Linux working on it. It seems to be working fine. It just needed a liberal application of cooling. But other than just the SATA adapter got very hot is what it boiled down to. But otherwise, ZFS stuff is working. And then I'm curious to try and get ZFS stuff working on some of the bigger machines because, ZFS. Like that sort of stuff happens. People have random problems with little single board computers and hop into the Works on ARM channel and folks will help each other out. So
Yeah, there's some neat projects or, I mean, some embedded hacks and things that
Yeah.
it's fun to just see what people do in there. The one I really enjoyed from like last week was a guy by the name of Brian, I believe his name was, who picked up a KVM Thunder Axe that had been decommissioned from somewhere.
Yeah,
and
we're-
he's got it sitting on his workbench.
there's a few of them
regular-
floating around on eBay. Some of us are thinking about
His-
picking them up.
Like,
Yeah, with his, he's
For how
got a
much?
desktop
They're like
power
350
supply.
bucks, but they have no power supply, doesn't have all the case components,
No memory.
no memory, no storage.
So it's just a
So-
motherboard and
so there's a little bit of work to do.
CPUs, but he has Frankensteined this contraption together and it's booting. So
wish you hadn't told me that. Now I got to go on eBay.
Me too. Don't
but
feel
it's,
bad.
it's just it's fun to watch what people create.
Yeah,
in
I
that
was
channel.
avoiding it, and then this week I have a use case for it, and I was like, darn, now I need one.
All right, so are we wrapping up at
Nowish?
nowish? Oh, okay, so it's got. Oh, there's no one coming. Okay, that's fine. So I'm gonna invite everyone to look at worksonarm.com. Invite everyone to if you actually just search for that string on your favorite network, you'll probably find something. There's.
We're not on WeChat yet.
We're not on WeChat yet. We're not on CompuServe or Prodigy.
No, we're not on CompuServe, Prodigy, or AOL.
The biggest challenge some weeks is that there's so much going on that it's hard to figure out where to start. The long-term challenge is as people find us and the ecosystem continues to grow, which it is growing with new devices coming out, attracting entire new communities, like
Yep.
everyone using the Jetson Nano is suddenly a charter member of a new club.
Yep.
And those people haven't found them all of each other yet, and what we can do to attract those folks. The other big challenge from an organizational standpoint is helping people understand that the things that people do on single board computers are vitally important for the success of server stuff, because if it doesn't work in that little environment, then people have a very low confidence that it'll work in a big environment.
And we're starting to get a lot more interest in IoT related things too. Like we recently spun out a LoRaWAN channel from the Works on ARM channel so that folks could talk about that. And there's a lot of overlap there because a lot of the boards are ARM based.
Yeah.
And there's also a home lab channel for people who are Frankensteining old server hardware with bench power supplies to make it go, among other things. That's kind of spawned out of Works on ARM as well. So
Yeah. So it's one part software and
yeah.
and one part hardware, and just getting
Point
people going.
is come hang out.
You're there now. Okay, good. It's one sign up. Good. It's one sign up. So I'm going to wrap things up now. Thanks everyone for coming all this way. I know for some of you, which would be me, this was a very long journey. The process of assembling people together and face to face is incredibly important for this community, because even if you only see someone once a year or twice a year or once per job, that it's just really important to see people face to face. And then hope to see you online. Thanks very much.